Hello students, let us continue the session on surface area and volume. In today's session, we shall be solving optional exercise. May not be asked in the examination. However, the questions are very interesting and very tricky. With the practice of these questions, probably any question of the examination, usually you can solve it. Let's start with the first question. The first question here is a copper wire 3 millimeter in diameter is wound about cylinder whose length is 12 centimeter and diameter 10 centimeters so as to cover a curved surface area of the cylinder. Find the length and the mass of the wire, assuming that the density of the copper is 8.88 gram per centimeter cube. This is how it looks like. Copper wire is wound about a circular cylinder. The height of the cylinder is mentioned as 12 centimeter and the diameter is 10 centimeter and thickness of the wire or diameter of the wire is 3 millimeter. Let me mention, it can be observed that one round of wire will cover 3 millimeter height of cylinder. Yes, so we can find out the number of rounds. So the number of rounds will be equal to the total height of the cylinder divided by diameter of the wire. The height of the cylinder is 12 and the diameter of the wire is 3 millimeters, so it is 0.3 meters. 0.3 centimeters. So this becomes 120 divided by 3, which is 40 rounds. Yes, with this information we can find out the length. So length of wire required in 40 rounds will be equal to 40 times perimeter. So it is 40 times of 2 pi r. R is 5, so we get it as 40 times 2 multiplied to 22 upon 7 into 5. We get 8800 upon 7. This will be approximately equal to 1257.14 centimeter or 12.57 meters. And they have mentioned the radius of the wire. Radius of wire is half of 0.3, that is nothing but 0.15 meters. So volume of this will be in centimeters, sorry. So the volume of wire will be equal to area of cross section into the length of the wire. What is area of the cross section? Area of the cross section is pi r square, which will be pi times 0.15 whole square into the length of the wire is 1257.14. Since it is in the radius taken is in terms of centimeter, I have to consider the length also in terms of centimeter. We get the volume as, substitute the pi value as 3.14 and then simplify. Approximate value I am writing here. This will be equal to 88.898 centimeter cube. So volume we have found volume is 88.898 centimeter cube. Now we can find the mass. Mass will be equal to volume multiplied to density. The density is given 8.88, so 88.898 multiplied to 8.8, approximate value 789.41. It will be in terms of grams. Second question, a right triangle whose sides are 3 cm and 4 cm other than the hypotenuse is made to revolve about its hypotenuse. Find the volume and surface area of the double cone so formed. The double cone would look like this one. There's upper cone and the lower cone. Let me call the upper cone as cone 1 and the lower cone as cone 2. Then if 3 and 4 centimeters are the sides, then hypotenuse will be equal to 5. So the length of AC is 5. Since AB equal to 4 centimeter, BC equal to 3 centimeter, and the cone is revolving around the right triangle, so the length of AC will be equal to 5 centimeter by Pythagorean triplet. So I can find out the area now. Area of the triangle ABC will be equal to half into AB multiplied to AC. Here I have made mistake. Area of triangle ABC will be equal to half into, I'll consider the base as AC into the height OB. So half into 4 is the length of EB AC is 5 units, OB is, we found this will be equal to half into 4 into 3. Because this triangle we can consider half base into height. If this is a base, we can consider this as the height. So 4 and 2 they get cancelled, so OB will be equal to 2 times of 6 upon 5, 12 by 5, which is equal to 2.4. Now the volume of double cone will be equal to volume of cone 1 plus the volume of cone 2. Volume of the cone 1 is 1 by 3 pi r square h1 plus pi 1 by 3 pi r square h2. So 1 by 3 pi r square can be taken common, h1 plus h2. h1 plus h2 is nothing but AO plus OC, which is AC. So 1 by 3 into 3.14 into r square is 2.4 whole square into h1 plus h2 is 5. So roughly we get it as 30.14 centimeter square. This is about the volume. So surface area will be equal to the surface area of cone 1 plus surface area of cone 2, pi r L1 plus pi r L2. This will be pi r common. We get 4 plus 3, L1 plus L2 is 4 plus 3. This will be equal to 3.14 into 2.4, radius is 2.4 into slant height sum is 7. So approximate value we get it as 52.75 centimeter square. So we have found the surface area and volume of the double cone. Question number 3. Important, a cistern internally measuring 150 centimeter into 120 centimeter into 110 centimeter has 129600 centimeter cube of water in it. Porous bricks are placed in the water until the cistern is full to the brim. Each brick absorbs 1/7 of its own volume of water. How many bricks can be put in without overflowing the water, each brick being 22.5 centimeter into 7.5 centimeter into 6.5 centimeter. Here, the volume of cistern will be equal to 150 into 120 into 110. We get it as 198,440 centimeter cube. This is the volume of the cistern. Volume to be filled. Volume to be filled in cistern will be equal to the total volume minus the volume of the water which is present now, 129600. The difference is 1850400 centimeter cube. Volume of one brick will be equal to length into breadth into height, 22.5 into 7.5 into 6.5. We get it as 1096.875. If it is absorbing 1/17th, not 7th, 1/17th of its own volume of water, so volume of water absorbed by these bricks will be equal to volume of water absorbed n by 17 times. If n number of bricks are there, n by 17 times 1096.875. So what do we conclude? We can conclude that volume of the brick volume which can be filled 1850400 plus the volume of water absorbed by the brick, n by 17 times 1096.875 equal to the volume of brick. This will be 1850400 equal to 16 n by 17 times 1096.875. So n value we need to find. N will be approximately 1792.41, approximately equal to 1792 bricks. So 1792 bricks were placed in the cistern. Question number 4. In one fortnight of a given month, there was a rainfall of 10 centimeters in a river valley. If the area of the valley is 1780 kilometers square, show that the total rainfall was approximately equivalent to the addition to the normal water of 3 rivers, each 1072 kilometer long, 75 meter wide, and 3 meter deep. Here they have mentioned the rainfall. So the rainfall in the river valley is 10 centimeter. In terms of meter, it will be 0.1 meter. They have given the area of the river valley. It is 7280 kilometer square. This will be in terms of meter, will be 7280, followed by kilometer in terms of meter, 1000 into 1000. I'll write it as 10 raised to the power 6 meter square. Because 1000 into 1000 is 10 cube into 10 cube, so 10 raised to the power 6. So volume of water will be equal to area into the height. Height is nothing but the rainfall. So volume of water will be 7280 into 10 raised to the power 6 into 10 to the power minus 1. We get 7280 into 10 raised to the power 5 meter square. Sorry, meter cube volume. Now, volume of one river is volume of 3 rivers, directly I'll find, will be equal to 3 times. What is the volume of one river? It is 1072 kilometer. In meters it will be into 10 to the power of 3 into 75 into 3. So what will be the value? This will be 9 times. So 9 multiplied to 75 multiplied to 1072, 10 to the power of 3 meter cube. Approximately we will get it as 7326 into 10 to the power of 5 meter cube. Observe the values here, they are almost equal. Yes, almost equal. So 7326 into 10 to the power of 5 is approximately equal to 7280 into 10 to the power of 5 meter cube. This also is in meter cube. If you round off to the nearest hundreds, they will become equal. So approximately they are equal. Question number 5. An oil funnel made of tin sheets consists of a 10 centimeter long cylindrical portion attached to a first term of cone if the total height is 22 centimeter, diameter of the cylindrical portion is 8 centimeter, and diameter of top of the funnel is 18 centimeter. Find the area of the sheet required to make the funnel. 18 centimeter is the diameter, and the radius becomes 9 centimeter, and for the lower base of the first term, the radius becomes 4 centimeter, and for the cylinder's height, it will be 10 centimeter, and 12 centimeter will be the height of the first term. Let me mention certain given things here. Radius R1 of upper circular end of first term is 9 centimeter. Radius R2 of circular ends lower part of first term is 4 centimeter, and the height of the first term is 22 minus 10, 12 centimeter, and height of cylindrical portion is 10 centimeter. Here we need to find the slant height. How do we find the slant height? The slant height is given by root of r1 minus r2 whole square plus h square. Let us substitute the value. We get 9 minus 4 whole square plus 12 square. It becomes 13 centimeter. So area of tin required will be equal to the curved surface area of first term plus the curved surface area of cylindrical part is given by pi 22 by 7. R1 plus R2 is 9 plus 4 into 13. 13 is a slant height plus 2 times pi 22 by 7 into RH. R is 4, H is 10. Let us find that out. 22 by 7 is being common. Rest of the things I'll multiply and simplify. We get it as 22 into 249 divided by 7, approximately equal to 782, 4 upon 7 centimeter square. Here, now we'll further simplify. So approximately this will be equal to 782.517 centimeter square. This will be the amount of the tin required to make the funnel. Question number 6 is the derivation of the total surface area of the first term of a cone that we have discussed. The same thing should be done here. And question number 7 is to derive the formula of volume of the first term, which is also discussed in the previous video. With this, I'll end today's session.